This call is now being recorded.
Hello everyone. So let's wait for some time. So I'll be waiting for some like 5 minutes. Then we will be starting this session. Okay, so we'll start today's session now. So let me introduce myself first. So my name is Himanshi Singh. I'm currently a PhD scholar at the Department of Mathematics, IIT Jodhpur, and I'm pursuing my PhD in broad area of probability and statistics. And I'm your TA for the course Essentials of Data Science with our software 2, Sampling Theory and Linear Regression and Analysis. And it is being taught by Professor Stella Bond, the NPTEL portal. So, so, so today, this is our live session 4. Okay, so we already conducted 3 live sessions. Okay, and this is our fourth live session where we will be discussing the week 4 content, which has been already uploaded on the NPTEL or SWAM portal. Okay, so this is the live session schedule. We are on the fourth live session. Okay, and this live session, we basically conduct this live session on every Monday from 6 to 8 p.m. Okay. Apart from this, these are the important links. First is the Google Meet link, which you can by which you can join this meeting. Second is the YouTube link where I upload all the recordings for the lectures. This is the link to my YouTube channel. Okay, you can access all the videos or the recordings of the class there. Okay, apart from this, this is the Google Drive link where I will be uploading all the R scripts and the presentations which I'm discussing here. Okay, so you can access them access them using this link. Okay, so this will be our plan for the live session. So first of all, I will giving you a brief recap about the topics which has been covered in a particular week's content. Then, if concept in R also, then we will be solving some of the practice examples. And ask if you have. Okay, so we will be discussing then. First discuss about the topics which has been covered in week 4 content. Okay, so let me first share my screen, no, not the window. So just give me a minute. Okay. So, in the previous lecture, we have discussed about the we have discussed about generating a sample using the command this sample. Okay, so we have discussed this function in order to generate a simple random sample with replacement or without replacement. To true if we want the simple random sample with replacement, and replace to be false if we want without replacement. Okay. So apart from this sample command, we also have a different way in order to generate a simple random sample without replacement. Okay. Functions need this. Okay, so we are basically installing this package called sampling using this command install.packages. So this package can be installed by using this command, and then we first will call this library sampling. Okay, in order to use the functions which are present there in this package to generate the simple random sample with and without replacement. Okay, so first of all, install.packages. So let me first show this commands in R. So this is the way by which we can install this package, install.packages sampling. So if I run it, so here in the left hand side you can see that I got this list from which I can choose any one. Okay, then this package will get installed in my system, or I can say in this software or the R, it will get installed here. Okay, then I can use the functions which are present in this package in order to generate samples. Okay, so here it is written the downloaded binary packages are in this folder. So basically it is downloaded. Now I need to call this package sampling. So for that I use this command library sampling. So if I call it, so I called it now. Okay, now I can use the functions called srswor and srswr. So these two packages we will be learning in detail about them. So these two functions are present in this package sampling. So in order to use these functions srswor, we need to first install the package sampling, and then we need to call this. So we already have done that. Okay, now uh, let us consider that x is a data vector, okay, which consists of population. Okay, so I want to select a sample from this data vector x. Okay, or and first of all we will consider the scenario when we are considering the simple random sampling without replacement. So for that we have this command srswor small n capital N, where small n is the sample size and capital N is the population size. So basically this srswor command will give me a vector of length capital N, which is the population size, and a vector of length capital N, and the entry of that vector will be either 1 or 0. Okay, the particular unit is present in the sample and 0 represent that it is not in the sample. Okay, for example, if I have this so for example, if I have this vector, for example, x is equals to c 2 3 4. So this is my population, suppose. Okay, now if I want to if I write srs WOR. So this is of size 3. So 3 is the population size. If I want to draw a sample of size 2, so I'll write 2 here. So this command will return a vector of length 3, one a kind of vector like 1 0 1, where there are two ones and 1 0 and total size is 3. And since the sample size is 2, I want, that's why there are two ones here. Okay, now this one represents that the first unit is in the sample, that is 2 is in the sample. Second is not in the sample because at the second place 0 is there, and at the third so I write 2 comma 4. So in this way this srswor is used to select sample from a population. Let me show how to get this sample. Let me show you show that to you in R. So here I consider this vector to be my population vector x. Okay, so if I run it, so I got this vector x to be the population vector. Okay, so this is my population vector. Then I consider this variable WOR where I'm storing the value SRSWR 4 comma 15. So basically what I'm doing, that the population size is 15, from that I want a sample of size 4. But here this vector will be, so here WOR will be a vector of length 15, which consists of entry 0 0 1 0. The entry can be 0 or it can be 1. Okay, now how to get the sample. So basically here what this vector is representing, that the first unit in the population, that is 4, is not in the sample, second is not in the sample, third is in the sample, 7 is in the sample, 0 is not, sorry, 9 is not in the sample because the entry is 0. Okay, the 10 is not in the sample, 5 is in the sample because here it is 1, and 3 is in the sample because here it is 1. So that happens. Now how to get exactly the sample? So here I got this vector, but how to get the sample, so that what will be the sample? So for that we this command. So here what I'm writing, x is a data vector, that population vector, and in the bracket I'm writing WR is equals to 1. So basically it is giving us those numbers in x, okay, for which this for those places where WR is 1. So if I run it, so here see that in 450 got this sample 75366. Uh, Random sample without replacement using the command srswr. Just remember one thing, that whenever I'm using the command srswr, it is not directly giving me the sample. It is first giving me a vector which consists of the entries 0 and 1. Then using that information, we are basically getting the sample by using this command, where I'm writing in the square bracket of x, I'm writing that whenever the vector, whenever the entry is 1, corresponding to those the entries of this population, that entry will be in the sample. Okay, so this is the way by which we can get a sample from srswr. Let us move towards the command srswr. So if I use this command srswr, this again will give me a vector of length capital N. But with when we are considering with replacement thing, then a single unit can have it can appear multiple times in the sample. So for example, if I have the same sample like this, same population like 2 3 4, then I can have a sample like 2 comma 2 of size 2. It can be 3 comma 3. Okay, so the units can be repeated. So here the outcome, in the outcome we have the entries, where the entries of that out the output vector of this command can be either 0 or 1 2 3 4, whatever. So it can be a positive real number, positive natural number, positive integer, I can say. It can be 0 3 4 there as of the output vector for this command. Number is represent that at that. So for example, if I write srs wr 3 0 1 0, the first position of the population, that element means this 2. Well, okay, this means the number or the entry which is at second position, that is 3, it appears twice, that is 3 3, and at the third position it does not appear in the sample. So basically this is saying, this output is saying this sample is 3 comma 3. About the numbers which the units which are present in the sample, if it is non-zero means that unit is present in the sample, and also magnitude of that number or that entry is the number of times that particular unit is appearing in the sample. Okay, so here it is written that the selected units from the data vector x can be obtained. I have a data vector x and I want to select that what are the units which are selected in the sample. For that, not equals to 0. So whenever it is not equals to 0, those values I want be the selected values. First of all, or in bracket to 0, those values will represent these are the number of replicates. So let me show that to you in R. Okay, so if I do it with replacement, so here I am storing the value of SRSWR 13, 15. So basically I want a sample of size 13 from a population of size 15, and I'm storing that to WR. So see here I got this WR. So let me show you that WR is this. So what basically it represents, so whenever it is non-zero means that particular value, so it is first at the first position it is non-zero, means the value at the first position, that is 4, this is in the sample, and since it is 2 means this appears twice in the sample. Okay, and at the second position it is 1, again it is non-zero, means 16 is in the sample. Okay, since the value is 1, so it appears only once. So uh, and again at the third position it is 0, means 7 is not in the sample. Again at the fourth position it is 2, means 9 is appearing twice in the sample. Okay, so this outcomes means, so this is showing us the replicates, and the non-zeroness is showing that the particular entry is in the sample. Okay, so what are the units which are in the sample? If I want to know that, so I write that x and WR is not equals to 0. So for which the WR is not equals to 0, I want those elements. So if I show you, so here it is saying that 4, 16, 9, 10, 3, 11, 67, 23, 27, 65, 60. These are the elements in the sample. But these are the elements in the sample, but how one may get repeated. So how number, what are the number of replicates? So for that I use this command WR, such that WR is not equals to 0. If I run this, so here these are the number of replicates. So this means 4 is appearing twice, 16 is appearing only once, 9 is appearing twice, and others all are appearing once only. Okay, so these are the commands which are used to obtain or generate a sample from a population, or collect a sample from a population. Okay. Okay, so this is about the sampling uh, package, and we are using two functions from that, that is SRSWOR and SRSWR. Okay, for both of them the outcomes are a little different. Okay, so you must have the understanding that what are the outcomes, what does that mean basically. Okay, we will be doing some of the question based on these two commands in the practice examples. Okay, so further we move towards the estimation of population mean. First of all, what is population mean? So we have two things, we have a population and we have a sample. Based on the sample we want to know about the population, because we cannot always do whole analysis on the population, because the numbers or the units in the population may be very large. So we need a sample. Now we have drawn a sample. In the previous classes we have learned a particular technique, that is the simple random sampling, replacement, without replacement. Now we know, okay, how to draw a sample. Now we have drawn a sample, how to know about the population using this sample, that analysis or that study will be now focusing on. So now if we have a population y1 capital, y2 capital, yn, small y1 to small yn to be the sample. Sampling. Now it can be with replacement, without replacement. So wherever it is necessary in the analysis, it will be mentioned that whether we are considering with replacement or without replacement. Okay. So now what about the population mean? Population mean is basically the average. Y1, Y2, Y capital N. Then if I consider this arithmetic mean, or the average of all the value, is my population. What is the sample? Now in practice we do not know all the values. Do not want to know, we want to do all the analysis using a sample only. So for that, if I have a sample small y1 till small yn, then the sample mean is given by the average of these sample values, that is 1 upon n small n summation yi. Okay, so this is the population mean and this is the sample mean. So we'll call them as a population and sample mean. Okay, then what we have, that y bar is an unbiased estimator of capital Y bar. So that is the sample mean. So the sample mean is an unbiased estimator of population mean. So which is basically means that expected value of Y bar is capital Y bar. Okay, so which basically says that for example, I consider that y1 be a sample. Okay, this is a sample number 1, for example, y2 is a sample number 2, y3 is a sample number of 3, and similarly whatever the number of samples which can be possible, so these all are y1, y2, y3 till if I'm using the sampling without replacement, then this will be NCN. Okay, so total number of samples can be the NCN. So these are the samples, so different samples. Now for each sample, the sample mean will be different. Okay, so for this will be y1 bar. Okay, for this it will be y2 bar, the sample mean. For this it will be YNCN bar. Okay, so for each of them, it will be different sample mean. Okay, now if I take average of all that, those sample mean, that is 1 upon n if I consider, not n, that is NCN, if I say, and summation I going from 1 to NCN, y, y bar NCN. If I take this, then this will be equals to y bar. That is the population mean. So basically the unbiased estimated thing means this. That if I, so whatever the number of samples which are possible, if I consider all the samples, and for each sample if I calculate the average, and then I calculate the average of all those averages, then that calculated average will be equal to the y population mean. And the unbiased estimator, so this unbiasedness property of an estimator. So one of the so unbiasedness is one of the properties of an estimator. So if an estimator is unbiased estimator, then we try to consider that estimator in order to estimate the parameter, in order to estimate the population. Okay, so mean, basically here we are considering this population mean. So it basically represents the central tendency of the data. So if we have some data, then what is the central tendency of that data means that what is the point where there is the majority of observations are there. There is a cluster around that point. So what is that point? So that is the central tendency of the data, and which basically okay. Apart from this, there are two samples who are having same central tendency, or the point where the population mean, or I can say the sample mean for both of the samples are same. Okay, now how to now say that which sample is better? Now in order to see that, we also have different is the population variance. So how the data is varying. Okay, so what is the variation? So in order to measure that, we use the term population variance. So represent that quantity population variance n summation yi minus capital Y bar whole square. So this will the values is the central of this is basically the center of the data. Okay, so the tendency. So this is basically the center, and I'm taking the distance or the difference between the quantity yi from, I'm squaring it and summing it and finding out the average. So this is basically the okay, and that where we have 1 upon small n minus 1 summation yi minus y bar whole square, I going from 1 to n. So this is the variance here. These are values, and where we have 1 upon n minus 1 summation whole square. And quantity which we will be considering further in order to find out several. Okay. Now talk about the unbiasedness, then this small s square. This is basically depends upon the sample only. So this small s square is an unbiased square when we be with replacement. If we are considering without replacement, this is unbiased estimator of capital S square. Okay, so this is an unbiased estimator of sigma square if we are considering SRS with replacement. Okay, and this is an unbiased estimator of capital S square if we are considering SRS WOR without replacement. Okay, and unbiased estimation means that expected value of S square is sigma square or expected value of S square is capital S square. Okay, so there is a difference SRSWR and SRSWOR. That's why this condition is happening, that the unbiased estimator of sigma square and S square is coming out to be S square under two different conditions. Fine. So this is about the population variance. Now further, if I consider, so y bar sample. So this sample mean is again a random variable. Okay, so here this can have a different values. As the value of the sample changes, the value of y bar changes. Okay, so so this is an the sample mean is an unbiased estimator of the population mean. But what about its variance? Okay, so the this is an unbiased estimator, but what about the variance? So this y bar, if I consider with replacement thing or without replacement thing, y bar will always be an unbiased estimator of the population mean. But what about the variance of y bar when we are considering with replacement technique, and variance of y bar if we are considering with replacement thing? Is there any difference between these two variances, or are they equal, or one of them is other? So then it will be easy to see that which for which condition we are having a more efficient estimator. More efficient estimator means whenever the variance is low, that estimator will be efficient. Okay. So under SRSWOR, it's been like discussed in the class that variance of y bar under without replacement technique, the variance of y bar is capital N minus small n divided by capital N into small n into S square. Okay, and the under SRSWR, the variance of y bar is n minus capital N minus 1 divided by capital N into small n into S square, which is also equals to sigma square by n. Okay, and if we compare them by certain manipulation, we can see that the variance of the y bar under the technique of with replacement is greater than variance of y bar under the technique without replacement. Means simple random sampling without replacement, the y bar is more efficient as compared to the technique with replacement. Okay. Also, now here this is the variances. So we got the variances, but since uh, we are not having all the population, all the values. S square is the term which consists, S square consists each and every entries in the population, that is y1 capital N. Sigma square is also consist of each population entry which is not always available to us. So we are wanting that, okay, we have this sample and now based upon this I want a conclusion. So uh, uh, for that we have this unbiased estimator of these two uh, quantities. So basically variance of y bar is this thing. So the unbiased estimator of this quantity is this capital N minus n upon capital N into small s square, when we are considering simple random sampling without replacement. Now, how is it happening? Because we discussed already that capital S small s square is an unbiased estimator of capital S square under the technique SRSWOR. Okay, so any if I multiply a constant here, then also that if I do the same multiplication here, then that also will be an unbiased estimator of that thing. Okay, so here capital N minus small n. So this is an unbiased estimator for the variance of y bar under w the without replacement thing, and small s square by n is the estimator of variance of y bar under with replacement thing. So if I have a sample, then and if I need to can be the estimate of variance of y bar, then I quantities. Okay, because I do not know the each and every entry of the whole population. Fine. So this is about this. Now we'll talk about standard deviation and standard error. So it is nothing, basically we want it is just a square root of the variance of y bar under both w without replacement and with replacement technique. So if I find out the positive square root of the variance of y bar, that will be the standard deviation. But since we want a only depending upon the sample, a square root of the estimate of variance of y bar we already know here, so we'll take the square root of them, and these are the standard error of standard or error of variance of y bar. So here we are okay, so here these are the expressions things. Okay, these are small s. Fine. So these were the concept which has been discussed in the lecture for week 4 content. Okay, if there is some doubt or something, then we can discuss that. Otherwise, I will start the questions. If there is some doubt, then please let me know. Otherwise, I will start the questions then. Okay, so then I'll start questions. I hope some of you answered the questions in order to make this class a little interactive. Okay. Okay, so this is question number 1. So which of the following can be a correct outcome of the command SRSWOR 412? Okay, so there are 4 options. Okay, only one can be correct or multiple options can be correct. So it is up to you. Just check all the options. So here we have SRSWOR 412. So basically we want a sample of size 4 from the population of size 12. Okay, so this SRSWR is the function which always will give us a vector of length of the population. Okay, so it will give me the first of all. Because of that, this second and third option is gone, because it will always be given of the size of the population. Now I want a sample of size 4. So for that, so not at least, we should have exactly 4 entries where 1 appears. Okay, apart from that, it should be 0 because we want a sample of size 4. So here, what does this mean? There is nothing. This is wrong. Okay. This is in the sample. Places in the sample. So this is the correct option. Okay. 4 units out of 12 units in the population. Lower output will be this. basically tells us that the first, third, they all are in the sample, and they are appearing only once. Is it fine? Is it fine or any doubt for this question? Okay. If there is no doubt, then I'll move for the next question. Okay, so here we have this question: which of the following cannot be an outcome of SRSWR 3,8? So anyone wants to answer this? So now I want that which of the command or which of the output cannot be the outcome for this command SRSWR 3,8. So which cannot be an outcome. So here we have SRSWR 3,8 means we want a population of size, a sample of size 3 from population of size 8. So the output vector will be of size 8 where we have 3 entries which are 1. Apart from that we have all 0 entries. So in the first question first option we can see there are 3 entries which are 1. Okay, out of the 8 entries. So that option is that option correct? Yes, that is correct. So here in the question it is, yeah, third cannot be an outcome. Why? Because we have 4 entries which are 1. Yeah, correct. So here the third is the right option. Because here we have 3 entries which are 1, here also we have 3 entries which are 1, and here also we have 3 entries which are on 1, and all these entries are total entries are 8 only. So in here we have 4 entries which are 1. That means we are having a sample of size 4 out of the population of size 8. So that is an incorrect outcome. So here in the question that was only asked. Okay. So now let me move for the next question. Okay, how many ones must appear in the output of SRSWR 5,20? So now from the previous questions, it is quite clear that how many ones should appear in as an output of this command SRSWR 5,20. So we want a sample of size 5 from a population of size 20. So how many ones will be there in the output vector of this command? Yeah, 5. So yeah, so there will be 5 ones in the output. Okay, now the position of those ones are random. So here it is written random, but the number of ones will be fixed, but their position will be random. So each time if I run SRSWR 5,20, the position of those ones must be changing. Okay, but the number of ones will be same. Okay. So in the next question it is written, which of the following is always true for the output of SRSWOR n, n? Okay, which of the following is always true? Fine. So the vector is sorted. So whenever we are getting a vector out as an output of this command, is that vector sorted? True or false? Is that vector sorted? Sorted basically means that the vector is in ascending or descending order. So is that vector sorted whenever I'm getting an output for this command? So the first option, is it true or false? So as an output of SRSWOR, yeah, so the vector is not sorted. So here it is false. Okay. Now what about the second part? So exactly n components equal 1. Small n. Exactly small n components equal 1. So is it true or false? So here in this command, exactly n components equal 1. Why it is false? So whenever I'm drawing a sample of size small n from from a population of size capital N, exactly n components should be equals to 1 na? Then only we will say okay, these are the positions for whose the units in the populations are in the sample. So here if I write SRS, so in the previous example only I can show you. So here you can see in this question, how many ones must appear in the output of this? So how many ones will be there? Five ones will be there, and exactly five ones will be there because I want a sample of size 5. So ones should be 5 only. So same question, same thing is this saying that here I want a sample of size small n. Okay, now how many components of the output vector of this will be capital 1? Yeah, so it will be exactly, so it will be true. Fine. Values range from 1 to n. So the output vector of this command, the values in that output vector, does that range from 1 to capital N? So is it true or false? Yeah, it is true. Sorry, it is false. Yeah. Because why? Because the values will be, so I will write it, values will be either 0 or 1. Okay, fine. So the vector has length small n. Is it true? So the vector has length small n. So the output vector, the length of that output vector, is it small n or is it capital N? So is it false or true? Yeah, it is false because so the length is capital N. So the vector, the output vector, I'm talking about the output vector of this command. So here the output vector of this command will be a vector of length capital N, where entries are either 0 or 1. Okay. Okay, now we are done with these questions. So we'll move forward for the next part. Okay. So which R command converts the output of this into labels of selected units? Okay, so what is basically, so this command will give me what? So this command will give me one of the outcome can be 1 0 1 0 0 0 1. So this is 1 2 3 4 5 6 7 8 9 10. So one of the output can be this for this command. Okay, now I want that which R command converts this output into labels of selected units. Okay, so here for example I have this population of size 10, for example 2 3 4 5 8 9 10 1 2 3 4 5 6 7 8 9 10. So this may be a population if I'm considering. Okay, now the labels of this population is this is 1, this is 2. So these are the label 3, 4, 5, 6, 7, 8, 9, 10. These are the labels of the population. Fine. Now I got this output. Now which command out of these four will give me these labels? So labels of the selected units. So the units which are selected, for example, here it is showing that here it is 1 means the first unit is selected. Here it is 0 means the second unit is not selected. Here it is 1 means the first third unit is selected. Other these three units are not selected. Then again it is 1, so this 5 is selected. So seventh unit is selected. Okay, so I want this quantity 1, I want 3, then I want the other quantities. So those labels I want corresponding to to them, the units are selected. So which command will give me first, second, third, fourth? Just think about it and just tell me that which command will give me this labels of the selected units. See, let me start with the last one. Table SRSWR 3, 10. What this will give me? This will give me, so here SRSWR is having entries 1 and 0. So table will give me that how many entries are 1, how many entries are 0. No, 4, not fourth. Okay, let me show that this thing in R, okay? Then it will be more clear. Okay, so here, what is the question? WR 3, 10. First of all, okay, let me store this in WR first. Then it will be nice. Okay, so we have WOR to be this vector. Okay. Now let me consider again a vector of length 10. So that will be my population vector. Okay. So that is C 3, 7, 8, 9, 10, 34, 78, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, etc. Fine. So this is a vector of length 10. So I'm considering this to be my population vector. Fine. Now WOR is this thing, which is basically indicating that my first unit in the population is selected. Second, third, fourth, fifth are not selected. Sixth is selected. Seventh, eighth is not selected. Ninth is selected. 10th is not selected. So this is basically showing that. Now, I want in the question, so I want that which R command converts the output of this into labels of selected units. So labels of the selected unit means that this first unit is selected, so I want 1 there. Okay, so label is 1. Okay, second, third, fourth, fifth, sixth unit is selected, so means I want 6 next. Okay, seventh, eighth, ninth unit is selected, so I want 9. So I want 1, 6, 9 as my output. So what are those are the labels of the selected units. Okay, let me show you that what will be the outcome for this table command. So table. So here I've stored already this in WOR. So that's why I'm writing this. So just see here, yes, it is showing that WOR 0713. So this is basically showing there are 7 zeros in this data vector and there are 3 ones in this data vector. So it is not giving me the labels. Okay. Sort. So sort, we already know that sort is basically gives us the output in the ascending or descending order. So let me write that also. So sort WOR. So this is giving me this outcome. So this is again not labels of the selected units. Okay. Then again is S dot numeric. So this basically converts the data vector into numeric data vector. So let me show you S dot numeric WOR. So this is giving me the same data vector again, only it has changed the nature. So this was already numeric only. Now again It is not doing anything to this data vector. So basically now the last one is which WOR. So here we can see just wait a minute. Okay, which WOR is, sorry, here I should write equals to 1. Then it will give me. So I should, here there is a correction that I should write here. Equals to 1 basically. So we want those values, so those units which are selected, which is basically shown by 1. So I want which WOR equals to 1. So for which of the entries, for which of the labels, the WOR is 1. So that is first, sixth and ninth. Okay, so the answer will be the first one. So is it fine or is there any doubt? There was a little mistake in this option. So is it fine? Is it clear? Is it clear or any doubt?
No doubt.
Okay. Okay, then we move forward. Okay, so these are true false. So uh, SRS WOR samples with replacement. So does it samples with replacement? So what is the answer for this? True or false? So here WOR, so we are just representing it. So it is the simple random sampling without replacement. So it does not samples with replacement. So it is false here. So what about the second? The output of SRSWOR is an indicator vector. So indicator vector basically means that the answer is in either in 0 or 1. So whether it is there or not. So it is binary kind of thing. So it is an indicator vector. So it is true. Because the answer is in like either that particular unit is present in the sample or not present in the sample. Okay. Now the next one is a little important. Sample 1 to n comma n. So this basically we have learned in the previous classes. This command sample, which is sampling from the population 1 till n, and it is giving me a sample of size small n. And SRSWR small n comma capital N. It is also giving me a data vector where which basically helps us in creating a sample of size small n from population of size capital N. So does they give me same type of output? Just think a little, then tell me. So does they give me same type of output, both the commands? So is it true or false? So are both these commands giving me same type of output? False, yes, because in the first command, it is giving me the sample. Directly, it is giving me the sample. However, in the second one, it is giving me a data vector of length of the population size, that is capital N, where we are getting 1 and 0. And from there, we can get, using some different command, we can get the sample, but directly we are not getting a sample. So they are not giving me the same type of output, so it is false. What about the next one? The sum of the output vector of SRSWR equals n. So is it equal to n? So is it equals to n? The sum of the output vector. So if I got this output vector in the form of 0, 0, 1, 0, 1 and this, and if I sum those values, then is it equals to small n? No. Why? Okay. So if I have a if I do this SRS WOR, so why n equals to 1? Small n is the size of the sample. Na? So for example, if I write small this SRS WOR 5 comma 10. So here my small n is 5, capital N is 10. Okay, this is the sample size, this is the population size. Fine, so here it will give me a vector. So one of the possible outcome is 1 0 1 0 1 0 1 0 1. Okay, one of the possible outcome is this. If I sum this, what it will be? It will be 5 only. So there are number of ones are equals to the number of the elements in the sample. So basically, if I sum the number of ones, that will be the sample size only. So that is n, small n only. Is it clear? Okay, so this is true. Fine. So we have discussed about SRSWR. Okay, now we'll discuss about SRSWR. So which of the following can be a correct outcome of SRSWR 3, 5? There can be more than one answer, more than one option that can be correct. So just see the option carefully and tell me that which of the following can be a correct outcome for this command. Just a minute. Okay, first one. What about the second one? What about the second one? Why? Here, just see. Here we are doing, we are using the command SRSWR. So without is not, it is not without replacement. Now, whenever we are using the command SRSWR, then we can get repeated entries in the sample also. So the thing that we are getting in the outcome, that we are getting 0 and 1 only, that is true with for the case when we are doing the without replacement thing. But if we are using this simple random sampling with replacement, then the outcomes are different. Okay, so for that there is a condition that either the output vector will have the entries which can be, zero, which can be a non-zero entry, positive non-zero integer also. Fine. So which basically represent that, so if the first option is 10110, so it is representing that first unit is there in the sample, second is not in the sample, third is in the sample, fourth is in the sample, fifth is not in the sample. But the second option is say in the sample. Random sampling with replacement. So it is showing 2 here. So correct. For the outcome can be first also. Okay, the first is correct, but the second is also correct. Second can also be the outcome. Because here in the second one, we are having that the first unit is in the sample which is appearing twice, and the second unit is also appearing once. So there are total 3 units in the sample. Okay, and other units are not there. 000 is there. Okay, and I hope this first and second part is clear. Why the first and second part is correct. I hope it is clear. Is it clear? Yeah. So okay. So here this is correct. This is correct. Now third is not correct because here we know that we should get a vector of length whose length is the size of the population. Okay. So here this is wrong. Again, here we are having 1, 2, 3, 4, 5, 6, uh, uh, a vector of length 6, which is more than 5. So this is also wrong. Okay, so these two are correct. Fine. So now the next question. Which of the following cannot be an outcome of SRSWR 4,6? So here we are using the SRSWR. Okay. So here SRSWR is the command where we are sampling. We want a sample of size 3 from the population of size 5. Fine. Now, when we are using this simple random sampling with replacement, then output can have, or I can say the output vector can have entries ranging from 0 to capital N, that is 5. Okay, because here what basically this will give us, the output for this command will give us, first of all, whenever the entry is whenever the entry is non-zero. For example, the output is like 5 not 5 3 comma 0 comma 0 comma 0 comma 0. So for example, this is an output. So what basically this is representing, that the first, so at the first place it is non-zero, means first unit is there in the sample. Okay, first unit is in the there in the sample and it is appearing. What 3 is showing, that it is appearing, the first unit is appearing thrice in the sample. And the second unit is not appearing, third is not appearing, fourth is not appearing, fifth is not appearing. So the outcome can be, here it can be 2 and here it can be 1 also, and there can be 1 1 1 also. Okay, because here we are using this command SRSWR where we can have a repeated entries in the sample also, because we are using the with replacement technique. Once we drawn a particular unit, then again we are replacing that particular unit in the population, and then again we are drawing a sample. So the same unit can come twice also, it can come thrice also. So here the output can contain entries, so this is not an indicator vector. So that was true for the SRSWR, that we will get an indicator vector. Okay, but here for this SRSWR, it is not true. We can get entries which are more than one also. We can get 2, 3, 4, 5, whatever the sample size, that maximum value can be. So is it fine? Now is it fine? Okay. So this is basically a procedure how the SRSWR command is working. Fine. Okay. So just answer this question now. So which of the following cannot be an outcome of SRSWR 4,6? Which outcome cannot be outcome? Which of the following option cannot be outcome for this command? So here fourth cannot be an outcome. Yeah, fourth cannot be an outcome because we are getting one, there are 3 ones. But not the sample of size 4. And in the third one, there are 4 ones. So that's fine. In the second, there are two, so that we are summing, so we are getting 4. In the first option also, there are the sum is 4. So yeah, you are correct. So the fourth one cannot be an outcome. Okay. Okay, the next question. If SRSWR 5, equals to 2102. Okay. So we are getting, so it is given that the output is 2102. So which unit is selected most frequently? First, second, third, or fourth? Which unit is selected more frequently? What is it showing? Output. What the output is showing? That which unit is selected most frequently? Is it first unit which is more frequent? Is it second? Is it third? Or is it fourth unit which is most frequent? So what basically it is showing the output, that the first unit is appearing twice in the sample, second unit is appearing once in the sample, third unit is not appearing at all, fourth unit is appearing twice in the sample. So that means that the first unit is also appearing twice, fourth unit is it also appearing twice. So these both units are the most frequently. So there is a tie that the first unit and the fourth unit both are appearing twice times. Okay, so here the answer will be first unit as well as fourth. Are you getting? Is it fine? What I'm trying to say. What about the frequency? Frequency basically means that how many times a particular unit is appearing in the sample. So here the output is showing the output is, so basically SRSWR 5,4 is the command which is used to draw a sample of size 5 from a population of size 4. Okay. Now since the population is larger is smaller and this sample is larger, so for this there will be repetition. Obviously there will be a repetition. Now the outcome is 2102. So what this outcome means? So this outcome is meaning that the first unit is appearing twice because there is 2 at the first place. Second unit is appearing once because there is 1 at the second place. Third unit is not appearing at all in the sample because there is 0 in the third place. And fourth unit is appearing twice in the sample because there is 2 in the fourth place. Okay, so first unit is appearing twice and fourth unit is appearing twice. So, so their frequency are they are most frequent. Okay, fine. So we'll move for the next one then. Okay, so which statement is always true for SRS R comma N? All entries are either 0 or 1. Is it true? From the previous examples, is it true that all the entries from SRSWR N comma N is 0 or 1? Is it true or false? Wow. Here on explain that in whenever I'm considering uh, SRSWR, and with the replacement thing is there in the picture. So a particular unit can appear twice in the sample. Maybe like this also, like 21000. So here in this question, it is asked that the all the entries are either 0 or 1. So that is true for SRSWOR without replacement. But that is not true for the SRSWR. Because there in the outcome for the command SRSWR, we can have the entries like 1, 2, 3, 4 also. My voice is not clear. So is it breaking or there is a network problem or what? Is it clear now? Okay, is it clear now? Am I audible? Okay. So what am I asking that whenever I'm using, so if my voice breaks, then please let me know, okay? So which statement is always true for SRSWR small n comma capital N? Now SRSWR is the simple random sampling with replacement we are using. So the sample can have a particular unit twice, thrice, or four times also. So here in the question it is asking that also in the option it is given that all entries are either 0 or 1. So yeah, that is true for SRSWR when we were using without replacement thing. But in if we are talking about simple random sampling with replacement, then the output can also contain entry like 2, 3, 4 also, which basically shows that this particular unit is appearing twice, thrice, or four times in the sample. Is it clear? So, for example, for example, if I consider here WR, that is SRS WR 13, 15. I want a sample of size 13 from a population of size 15 if I run it. So here if I show you WR, here you can see that in the first place it is coming 5. At the fourth place it is coming 3, which is not 0, not 1. Which basically means that the first unit is appearing 5 times in the sample. Fourth unit is appearing 3 times in the sample. 15th unit is appearing 2 times in the sample. Okay. So here it is asking that the entries are either 0 or 1. So no, it can be other than 0 or 1 also. Is it clear now? So it is false. Okay. So the vector which we are getting as an output for this command, it is of length small n. So what will be the length of that vector? So it will be of capital N length. Okay, because in the output of both the commands, whether it is SRS WR or WR, the output vector will always be of length capital N. Okay. So it is also false. So it is of length capital N. Okay, the sum of the entries equals n. So yeah, so those entries, the sum of the entries will always be small n because that is the sample size I want. Okay, so the sample size or number of times it is appearing. So here also you can see that. Okay, I have not shared that screen. So wait a minute. Okay, so here I have this vector WR which is SRS WR 13, 15. I want a sample of size 13 from population of size 15. And if I see that this is a vector where we are getting 5, 3, 1, 2, 0. So so no, not only 0 and 1, we are getting other values also. Okay, now in this question, it is asking that sum of the entries equals to n. So here also you can see that I want a sample of size 13. Okay, so this 5 plus 3 plus 1 plus 1 plus 1 plus 2, it will be 13 only because I want a sample of size 13. Okay, so yeah, so it is true. Fine. All units are distinct. Is it necessary that all units are distinct? No, it is not necessary, so it is false. So they can be same also, can be distinct also. Fine. Okay. So, okay. Uh, in this question, it is asked that which R command converts the output of SRSWR and comma n into sampled labels. Okay, so which command will tell me that the which command will convert the output for this into the sampled labels? So see, table will not give, because table will always be giving how many zeros are there and how many ones are there, how many twos are there, how many threes are there. Okay, so this will not give. S dot numeric will not change anything. It will only convert the nature of the data vector. Okay, so this will also not give. Now there are two options with us. REP 1 till n, SRSWR n comma n. So this basically is the repetition command. So for example, let me take a particular value of capital N. Let capital N be 4, small n be 2. Okay. Now or I can take small n to be 3. Okay. So if I find REP 1 till 4, comma SRSWR small uh, uh, 3 comma 4, this one. So it will give me a vector. It will give me a vector like, for example, I want a sample size 3, so I want 2 here. Maybe this can be an outcome. This may not be always be an outcome. This can be an outcome. 2 here. Okay, 0 here, 1 here, 0 here. So this can be an outcome for this command. What basically it is doing, 1 till 4, comma, so this is C, okay, this. So it is, so this command will give me what? That 1 is repeated twice, 2 is repeated 0 time, 3 is repeated 1 time, okay, and 4 is repeated 0 times. This is bracket. So this command will give me 1, 1, okay, and 2 is repeated 0 times, so 2 will not be there. 3 is repeated 1 time, so 3. 4 is repeated 0 times, so it will give me 1, 1, 3. So however, what will be my sample? That first unit. So if this is my population, y1, y2, y3, y4. So the first unit is appearing twice. That means in the sample we have y1, y1 two times. Okay. Second is appearing 0 times. Third is appearing 1 time. So this is y3. So we have this as my sample. So this is my sample according to this one. Okay, this is my sample. And I want the sampled labels, means I want 1, 1, 3, and which is this command is giving me. Okay. However, if I use which command, so this is correct. If I use which command, for which command, if I use SRS WR 3 comma 4, for example, is equals to 1. Similarly, as we have done for the uh, SRS WR case, if I do this thing, then it will give me, so it will, or not equals to 1. For this I should write not equals to 0, because here we also have not equals to 0. Okay, so for not equals to 0, it will give me the first position, so that is 1, and for second it is 0, third position 3. So it is also giving me 1 and 3, but these are not the labels for all the sample values. Okay, so it is showing me that y1 comma y3 is in the sample. So this is the sample basically. However, this is showing me that y1, y1, y3, this is the sample. So this command is true, not this one. So this all is happening because of the repetition, the occurrence of the repetition in this command SRSWR. However, all this complication was not there when we were doing the simple random sampling without replacement. Okay, is it fine or some extra explanation is needed? Okay, so shall I move forward for the next question? Fine. So now, so we have done like elaborated discussion about SRSWOR and SRSWR. Now we will move towards one more question on this one. Then we'll move towards the that sample population or the the sample mean and the population mean thing. Fine. So this one more question on this concept, that write R commands that converts the output of SRSWOR n comma n and SRSWR n comma n into sample obtained from population stored in a vector X. So for example, here I have a data vector X, okay, which is a population, which consists of the population. Okay, so there can be some entries here. Okay, now SRSWR will give me a vector of length capital N, which is having entries 1 0 1 0 kind of thing. It is not giving me directly the samples. Okay, so in order to get a sample, okay, so SRSWR I'm considering. In order to get a sample, so I will write the command X, and in the bracket I will write uh, SRSWR, those values n comma n which are equals to 1. Okay, so those values for which, so for which this SRSWR equals to, this will give me the indices for which this SRSWR is equals to 1, and those indices will be applied here, and those corresponding values of X will be given. Let me show this to you in the here. So here just see that X is a population vector. Okay. Here I have stored SRSWR 4 comma 15 in WOR vector. So here just X is a data vector, population vector. WOR is the SRSWR 4 comma 15. We are drawing a sample of size 4 from a population of size 15. Okay, if I write X such that WR equals to 1. So see, WR equals to 1 is basically comparing. So here, if I show you what WOR is, WR is this. Now WR equals to 1 will give us false here, false here, false here, true here, false here, true here, false here, false, 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 true here, false here, true here, false here, false here. This command. But if I write this in this bracket of X, then it will give me, so whenever there is true, it will give me that place value here. So if I write this command, so it is giving me 9. So this basically, 1 is at fourth position, so it is giving me 9. Okay, 1 at sixth position, so it is giving me 5. And 1 is here, so it is giving me 23. So wherever there is 1, those values, those position value, it is giving me. So basically this command is giving me a sample of size 4 from a population which is stored in the data vector X. By using SRSWR, we are only getting a vector where we are having entry 0 and 1. Now from that output, here I am getting this sample. Okay, so this is quite easy for SRSWR, but if I consider SRSWR, then how to get it? SRSWR, if I do. For that, I have to see here, I have shown you this repeat command, same command we will be using. So here we will be getting X such that, so here SRSWR is not 1. Sorry, not 0, those values we want, so that SRSWR is not 0. Okay, so it is first of all, here it will be WR we have done, so it is, okay, it is REP, that same command we are using. So we will repeat the values of X the times there are number of replicates. So X comma, a replicate we are getting by using SRSWR n comma n. Okay, so this SRSWR n comma n will give me output like 2, 3, 0, 0, 1, such kind of thing. Okay, and X here is the population vector. Okay, for example, it is like 24, 30, 21, 36 or 29, this kind of data vector. So this command will give me what? So not here, it is not not square bracket, it is the curved bracket. 29 is repeated twice, 29, 29. 24 is repeated thrice, that is 24, 24, 24. 30 is not repeated, 21 is not repeated, and 36 is there. So it is giving me this sample. So basically this will be the sample for that. Okay. So here we are having a simple random sample of size 1, 2, 3, 4, 5, 6, of size 6 from a population of size 1, 2, 3, 4, 5. Okay. So is it fine? Fine. How this repeat command is helping us to get the sample. Okay. Fine. So then now this SRS and SRSWR thing is done. Now we'll move towards the sample mean and the population mean and the unbiased estimator thing. So we have studied in the class that the sample mean is an unbiased estimator of the population mean. Okay, whether we are considering simple random sampling with replacement or we are considering simple random sampling without replacement, for both of the cases, we know that the sample mean is an unbiased estimator of the population mean. Okay, so here in this question, it is given a sample of size m is drawn by simple random sampling without replacement and the sample mean is y1. Okay, another sample of size n is drawn and the sample mean is y2. Okay, so here we have a sample of size m for which the sample mean is y1 and a sample of size n for which the sample mean is y2. Okay, let C to be equals to m into y1 plus n into y2 divided by a plus b, where a and b are some non-zero scalars. Then which of the following statement is true? Y1 is an unbiased estimator of the population mean. Y1 is what? Sample mean. And sample mean is an unbiased estimator of population mean. We have already studied in class. So this is correct. Okay, so this statement is true. Fine. Y2 is an unbiased estimator of population mean. Y2 is again a sample mean when we are using the simple random sampling with replacement. So it is again an unbiased estimator of the population mean. This is also true. Now, C is an unbiased estimator of population mean. Is this C an unbiased estimator? So let us see. So C is what? M into Y1 plus N into Y2 divided by A plus B, where we have the information that y1 and y2 both are unbiased estimator of the population mean. Okay, now now whether C is an unbiased estimator or not, in order to check that, we should first see that whether the expectation of C is equals to the population mean or not. Okay, so first of all let us consider let us consider y bar to be the population mean. Okay. Okay, and we know that expected value of y1. Okay, so that this is a sample mean is equals to y bar. This is an unbiased estimator and which is equals to expected value of y2, because y1 and y2 both are unbiased estimator of the population mean, that we know. But if I consider C, so if I take expectation of C, now here this is C. So here this is a scalar, so it can come out of the expectation. So that is basically the mathematics or the algebra of the expectation, that if there is any scalar in the multiplication, then it can come out of the expectation. So here m is again a scalar, that is the size of the sample. So here 1 upon a plus b, m into expectation of y1 plus n into expectation of y2. So the expression will be like this. Okay. Now we know that expectation of y1 and expectation of y2 is y bar. Okay. So it will be like m plus n upon a plus b into expectation of, not expectation, expectation of both of expectations are equal and this is equals to y bar. So this is y bar. Now C is an unbiased estimator if Unbiased estimator of what? Of y bar if expectation of C is y bar. Fine. But is expectation of C in general equals to y bar? No, because there is a scalar. Now this scalar can have any value. So it is not exactly equals to y bar. So in general, it is C is not an unbiased estimator. Okay. So here it is C an unbiased estimator of the population mean? No, it is false. Okay. In the next question, it is asking then under what condition C can be an unbiased estimator? So under what condition the expected value of C is y bar? Whenever this quantity is equals to 1. So if m plus n upon a plus b is equals to 1, then expected value of C is what? So that will be y bar. Implies C is an unbiased estimator of y bar. Okay, so if this m plus n upon a plus b is equals to 1, then we can say that that C is an unbiased estimator. Otherwise, in general, we cannot say that the C is an unbiased estimator. So is it fine? Okay. Okay. So then we will move forward. So this is basically the unbiasedness thing of the, and when can we say that if so basically here in the question in this C is basically a weighted average of two sample means. Okay, so when the weighted average is the weighted average will be again an unbiased estimator whenever if we are considering the coefficients and the sum of the coefficients is unity, then that weighted average is again an unbiased estimator, otherwise it is not. So basically that thing I want to tell you using this example. Fine. So so we'll move for the next question then. Okay. A sample of size small n is drawn from a population of size capital N. A sample of size 2n by 5 is drawn by SRSWOR. A sample of size 3n by 5 is drawn by SRSWR. So let first of all, this size of sample is drawn by SRSWR. So by SRSWR, a sample of size, let us name it as n1, which is equals to 2n by 5 is drawn. Okay. And by SRSWR, a sample of size n2, which is 3n by 5 is drawn. Okay. This is by SRSWR. This is by SRSWR. Then calculate ratio of variances of sample means. Okay. So here one sample is collected. Here one sample is collected with certain n1 sizes and n2 sizes. Okay, so here the sample, let us consider that it is y1, y2, dash 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 yn1. Okay, and here the sample is y1 dash y2 dash till yn2 dash. This sample is collected. Okay, now the mean for this sample, let us consider the sample mean to be y bar. Okay, and for this it is y dash bar. Okay, the sample mean. Okay, or I can also say it as a WOR, or this is for WR. Okay, now then we want to calculate the ratio of variances of the sample mean. So the ratio is equals to variance of y bar, this is for WOR, divided by variance of y bar WR. Okay, now we know that variance of y bar under SRSWR is what? So this variance. So for without replacement, it is capital N minus the sample size, which is n1, divided by capital N into n1 into s square. Okay. And for WR, it is variance of y bar. For with replacement, it is capital N minus 1 upon n into small n2, because the sample size is n2 here, into s square. Now what n1 is? So n1 is 2n by 5. If I replace it here, so it is n minus 2n by 5 divided by n into 2n by 5 into s square. So which is equals to 5n minus 2n divided by, so this 5 and this 5 will get cancelled. So it is 2 into n into n s square. And what this is, so this is n minus 1 upon n into, so this is 3n by 5 s square. So this is equals to 5 into n minus 1 s square upon 3n into n. Okay, so then, so if I take the ratio, so ratio is equals to, so this is 5n minus 2n divided by 5 into n minus 1. Here it is 2 into n and upward, so n will get cancelled, and and this will be 3 by 2 here. So that will be the ratio. So it will be, so what it will be? It will be 3 into 5n minus 2n divided by 10 into n minus 1. Okay, is it correct? Is it fine? Is it fine? Basically, here we have two samples. First, we are drawing by simple random sampling without replacement, and another we are drawing with replacement. And sizes of the sample is small n1, small n2, which is 2n by 5 and 3n by 5. Okay, we consider. So we want to find out the ratio of the variances of sample mean. So variances of sample mean is y bar whenever we are considering without replacement, divided by variance of y bar whenever we are considering with replacement. Now for both of them, we know the expressions. That variance of y bar whenever the random sampling is without replacement is n capital the population size minus sample size divided by their product into s square. Okay, for both for with replacement, we have the population size minus 1 divided by population size into the sample size multiplied by s square. For both of them, we just put the values of small n1 and small n2, which is 2n by 5 and 3n by 5. We found out the value and then we just calculated the ratio. Is it fine? Okay, so we just calculated the ratio. Fine. So then we'll move for the next question. Okay. So from a population of size capital N, a sample of size small m is drawn by simple random sampling without replacement, and a sample of size small n is drawn by with replacement. Find the condition on m and n such that variances of sample mean under both of the conditions are equal. So basically what we want, that the variance of the sample mean y bar under SRS WOR is equals to variance of the y bar under SRSWR. And we are not taking the sample sizes to be equal. Here M and N are different. They are not equal. So what is the condition on that small m and small n such that both of them are equal? Okay. So what is the first of all the expression for the SRSWOR is the population size minus the sample size. And what is the sample size is small m. Okay. So this is small m divided by n into m multiplied by s square. What about this thing? So this is n minus 1 divided by capital N. And what is the sample size? So small n. So that is small n into s square. Okay. So what is the condition? So both of them are equal. So this s square and s square will get cancelled. So here this n and n will get cancelled. So n is equals to m times n minus 1 divided by n minus m. So whenever this condition holds, both the variances will be equal. Okay, so this basically is the condition under which both the variances will be equal. Fine. Okay. Okay, so here is one other question. So two independent sample of size 40 and 20. First of all, they are independent samples. Okay, both the samples are independent. So here we have this sample like 1 y1, y2 till y40 and y1 dash, y2 dash till y20 dash. So both of them are independent. Okay, now population size capital N is 200. Then find the variance of sum of sample means. For this let sample mean be y bar, and for this let sample mean be, for this let be y1 bar, and for this let be y2 bar. Okay, the sample mean. So that is 1 upon 40 summation I going from 1 to 40 yi, and for this it is 1 upon 20 summation I going from 1 to 20 yi dash. Fine. So these are the sample means. I want variance of sum of sample means, that is y1 bar plus y2 bar. Okay, now these samples are independent. Okay, so the variance of this will be variance of y1 bar plus variance of y2 bar. So there is another term like twice covariance of y1 bar, y2 bar, but since they are independent, so that term is 0. Okay, so it is like variance of y1 bar plus variance of y2 bar only. Now y1 bar is with respect to the SRSWOR. Okay, so what will be the value for that? Capital N, which is 200. Okay, that is minus small n, which is 40 for this, divided by capital N into small n multiplied by s square, plus for the SRSWR thing. So y2 bar is the sample mean for the sample drawn from SRSWR. So here we will make that formula. So this is 200, that is capital N minus 1 divided by capital N into small n. Small n is 20. So here it is 20. Okay, multiplied by s square. And the question it is given s square to be 36. So we'll just replace it here. So the variance of y1 bar plus y2 bar is equals to, here it is 200 minus 40, so it is 160 divided by 428,000 into 36 plus this is 199 divided by 4,000. 199 divided by 4,000 multiplied by 36. Okay, so then we can just figure it out what it is. So it is like 8,000 here, 160 plus 199 into 2 into 36. Okay. And if you do the calculation, then you can get the answer. So it is like 160. So let me just find out. So it is Okay, and it is 160 plus 398 divided by 2000 multiplied by 9. So it is 8 here, 9, 6, 15, 5 here, 5 divided by 2, 3 multiplied by 9. Okay, and this 2, 2, 4, 40. This is 1000. Okay, and if you multiply it, so it is 9981, 63, 1 carry 7, 19, 20. 5 divided by 1000, so it is 2.51. So this will be the variance of y1 bar plus y2 bar. Is it fine? Only the calculation I have done here. Before that, the conceptual thing was mainly that why both the samples are independent. So the sum of the variances, so the variance of the sum will equals to be the variances, the sum of the variances, and from the SRSWOR and SRSWR, we already have the expressions for the variances of the sample means. Those we just put down here, and we have just used the value of S square to be 36, and we just calculated the variance of the y1 bar plus y2 bar, which is coming out to be 2.511. Is it fine? Okay. Okay, so now we will be discussing this last question. Okay, so what does it say? So it is about true and false. So variance of sample mean under SRSWR is independent of population size. So what is variance of sample mean under SRSWR? So if I discuss first one, so variance of sample mean under the technique of SRSWR is what? It is n minus 1 divided by n into s square. So is it independent of population size? Is it independent of population size? Population size is capital N, and population size is directly coming into the expression of the variance of y bar under the technique SRSWR. So it is not independent of the population size. This is highly dependent on population size, which is capital N. Okay, so this is false. Now for sample size, for the same sample size, sample mean under SRSWOR is always more efficient than under SRSWR. So this question we already done in class also. So if I consider variance of y bar under SRS WOR, so what is it? It is n minus 1 divided by n into n s square. Okay, so if I just add and subtract n from it, okay, so then it becomes n minus n upon n into n s square plus n minus 1 upon n into n s square, where this quantity is positive. Okay, or I can say positive only. Greater than equals to 0. It can be equals to 0 when n is 1, no doubt. Okay, so this, what is this? This is variance of y bar under the condition when we are considering SRS WR. So what it is implying, that variance of y bar SRS WOR, so this variance is greater than variance of y bar SRS WR. Okay, so which is implying that that y bar is more efficient. When it will be more efficient when the variance is less. So it is more efficient under SRS. So it is more efficient when we are considering it to be under. Wait a minute. So here this was SRS without. So I have written it wrong actually. So it is SRS WR actually. Okay, and here it is WR. So here it is WR and here it is WOR. So Y bar is more efficient. So here when under SRSWR without replacement, because the variance is more. Here I have written it wrong because n minus 1 upon nn is the expression for the without replacement thing. Sorry, with replacement thing. Okay, so here we can see that the Y bar is more efficient under the SRSWR and we are not imposing any condition. So it is always more efficient. So this is true. Okay. In the third part, it is asking that as capital N tends to infinity, variances of sample mean under SRSWOR and SRSWR coincides. So let us see. So the variance under SRSWR is capital N minus 1 upon N into S square. So it can also be written as variance of Y bar under SRSWR. It can also be written as 1 upon small n minus 1 upon capital N into small n into S square. Okay, now when capital N goes to infinity, this term will go to 0. So this term will go to S square by N as capital N tends to infinity. Again, if I consider variance of Y bar under SRSWOR, so that is what? So that is capital N here, capital N minus small n divided by this one. So this can be written as 1 by small n minus 1 by capital N into S square, which again will go to S square by N whenever N goes to infinity, because this quantity will go to 0. So as N goes to infinity, both are going to same quantity, that is S square by N. So this is true. Okay. So this is about this one. If there is some doubt, then you may ask in this question. Is it fine? Is it fine? Is this question fine? Okay. Okay, so this is all for today by my side. If anyone of you have some doubt, then you may ask. And apart from this, this recording I will be uploading on YouTube, and the R script and the PowerPoint presentation will be on the Google Drive. And deadline for the assignment is 18th Feb, and next session will be on 23rd of February. Okay. Now, if you have any doubt, then we may discuss that. Anyone? Okay, so if there is no doubt, then we'll end this session today, and let's meet in the next session on next Monday. Okay. Thank you everyone for joining. Okay. And we'll be meeting in the next session.